Hello and welcome to this short video in which we'll go over an example of a language learning activity in our ICALL ecosystem or intelligent call ecosystem. The ICALL ecosystem is integrated into the learning environments of the Spanish Corpus Annotation Project or SCAP. In a nutshell, the ecosystem enables users, which can be students, teachers, or even language professionals, to create intelligent, customized exercises and learning resources for Spanish as a foreign language. And while they are solving those exercises or using those resources, users should also gain metaskills, which allow them to get the most out of the learning environment. The focus lies on stimulating their curiosity, promoting their autonomy, and developing their technological skills. In the meantime, all activities and interactions of the users in the environment are anonymously collected as implicit crowdsourcing data to improve the quality of the learning materials. And this is where the ICALL platform becomes a fully fledged ecosystem. All right, high time we dived into it. The example in this video revolves around word sense disambiguation as the NLP-driven feature. In other words, the integration of word sense disambiguation into the learning environment should result in more intelligent, more customized exercises and learning resources, as they can be disambiguated now. As for the target setting of the video, you should imagine yourself in a language for specific purposes course on economic and business vocabulary. And in one particular class of that course, lexical ambiguity is addressed as the linguistic phenomenon under focus. Or the course includes an online learning module with lexical ambiguity as a topic. That would be another possible scenario. In any case, the goal is to learn lexically ambiguous vocabulary items linked to economics and business as the target domain. And in this context, you're taken to the learning platform to make some exercises. Let's go to Colaborar, which is the section where interactive exercises are offered, and then start a new exercise. We select lexical ambiguity as the type, and let's say divisa as the target item. And here's our exercise, or at least part one of the exercise. In part one, we're going to initiate the word sense disambiguation model by introducing into it one prototypical example sentence for each sense of the ambiguous item. And the introduction of those sentences into the word sense disambiguation model is done through a vocabulary learning exercise here. And the exercise is corrected automatically. So what we're going to do is, solve this exercise. We're going to make a mistake to see what happens. All right, so a message here at the top stating that a mistake has been made. The second sentence is highlighted, which means that the error is here. So indeed, divisas in this sentence means foreign currency. In the first sentence, it means emblem, motto, symbol. All right, so now the exercise is correct, and we can go on to the next part in which a graph will be shown, where those two sentences will be put into. All right, here's our graph, and above some information in which it is explained how those sentences have been transformed into vectors and put into this graph. Right, so this is the basic model, basic word sense disambiguation model, and we're going to see how well this model can predict new sentences, which is what's happening in the next screen, the prediction of new sentences. All right, here we see that two new vectors have been added to the graph. And by the way, those vectors are obtained by taking the contextualized word embedding of divisa in each of the sentences by introducing it into a transformer model. Right, so here the user is invited to think about the performance of the words and disambiguation model. So in other words, to see, well, if the first sentence, for example, which is located here, is close to its correct meaning, so either this dot or this one. And when we're going to the sentence, we see that the bisa is used as foreign currency here, and exactly, well, it's closer to the foreign currency vector than to the symbol motto vector here. And for the second sentence, well, that's the other way around. The bisa means symbol, emblem, motto in this sentence, and well, indeed, it's located closer to this sense vector than to the other one. So here the user is invited to think about the performance of that basic words and disambiguation model. In the second part of the exercise, user is invited to fine-tune the basic model that was built in the first part. And to this end, we offer the 10 sentences taken from corpora, which are available within SCAP. The 10 sentences which were the most difficult for the basic words and disambiguation model to predict. So this is also explained here in Spanish at the top. And then we explicitly state that the user has now the opportunity to introduce those sentences as additional sentences into the model, so to make it more intelligent, to provide more examples. And it's a targeted addition of examples because it's the 10 most difficult sentences for the system based on the first part of this exercise. So the user is invited to add those sentences by choosing the right sense here. And if the user is not sure, they can indicate or they can tick the box here in the otro or question mark column. So importantly, we also explicitly state that this part of the exercise is not corrected. The user here has to think autonomously which sentences he or she will add to the model. So let's do the exercise. Divisa means foreign currency here as well, symbol or lemma. All right, so this should be correct. This is what we think is the correct solution, and we want to add those sentences as extra input, extra knowledge to our model. And let's see what happens, what the new model looks like in the graph. And well, the exercise has generated a new graph, a new model here on the fly. So we can consult the 10 sentences we've added, which are numbered here in our graph, and still the two new sentences which should be predicted by the model are still included in the graph as well. So here at the top we have some we have put some questions for the user to think about if the new sentences have led to clearly delimited spaces, groups of vectors in the graph, or if it appears that two senses are located close to each other, the vectors of two senses are located close to each other, which would reflect some, well, link between those two senses. Here we clearly see that, for example, the symbol part of symbol motto part of the graph is here at the top right corner, and then the main part of the graph here is it can be attributed to the foreign currency meaning, and we still see that finally that the two new sentences are still predicted correctly by our system, and now we have a clearer view on how divisa is divided into its two different senses here in the new graph. So that's the goal of the second part of the exercise. And that's it. So in summary, the integration of words and disambiguation as such, first of all, enables the learning environment to offer disambiguated learning materials, right? So going back to our specific target context of economic and business vocabulary, this means that we can choose to exclude irrelevant meanings, such as divisa as emblem motto, for example, from our queries and only retain relevant meanings, for example, in the economic setting, that will be divisa as foreign currency. Next, this type of exercise also offers, let's say, pure practice opportunities, thanks to the first part of the exercise. Perhaps you can start a new exercise to go over that again for the target item tasa, perhaps. All right, so here, this is a pure vocabulary exercise. It's corrected, so the user gets feedback. So, for example, here, this is a kind of tax which has to be paid. That's in this meaning. Here is like a restriction, limitation, and here it's like a kind of index. So we can make this exercise. So this is a pure exercise for the student. And again, if we make a mistake, a message is here put on top of our screen. So we have to think about what's the correct meaning of the item in this sentence and learn from that. All right, and then the part where the graphs are shown is the part where the users can gain metaskills, as they see how words can be transformed into vectors, how these vectors can be used to distinguish senses, where errors made by a words and disambiguation system could come from, etc. So this is a part where metaskills can be gained. And here again, when the new sentences are put into the graph, that's a combination, okay, part metaskills, but part again being or engaging actively with the different meanings of tasa in this case, see how it is used in different contexts, so actively learning the different senses of tasa, of an ambiguous item. Right, and then in the second part of the exercise, the curiosity and autonomy of the users is stimulated, as they are invited to go on and fine-tune the basic words and disambiguation system from part one. And in the background, what users are indicating here, right, the results of this part of the exercise are anonymously collected and can then be used as additional labeled data to improve our words and disambiguation models. And then those improved models should lead to higher quality disambiguated learning materials, right? And there's more, because the data collected in this part can also be used to make new, larger exercises on lexical ambiguity. Because as soon as a few users make this exercise, we can join those results and get to know the correct sense of all of these sentences. Right, so if 3 users classify this first sentence as, well, let's say, for example, tax here, we can be pretty sure that tasa in this sentence means tax, right? And then we can use this knowledge to make new, larger vocabulary exercises. And that's it basically. This is what an exercise in our ICALL ecosystem more or less looks like and what it can be used for.